Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Also welcome to the NEET crash course series. Today in this class I will teach you the projectile motion, the theory which needed for the NEET exam. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you crack the NEET exam confidently with a good rank. Now let's start about the class. Today the class will be on projectile motion theory. Projectile theory. Some important problem I will discuss, but main NEET problems will be discussed in another videos. So there are also discussion have been made in another videos other than the main NEET theory required for projectile motion. I will discuss today. First, vertical projection. Suppose a body is projected from the ground with velocity u. Now the projection will be like this. So what have we discussed? That acceleration of the particle throughout the motion, what throughout the motion is g, which is vertically directed downward, which is vertical downward, and along same direction and along same horizontal level, upward velocity and downward velocity the same. We know already that is time of flight t equal to here 2u by g, and time of ascending and time of descending equal, and velocity at highest point equal to 0 is maximum height equal to u square by 2g. We know that. Now along same horizontal level, upward and downward velocity same. Now here important things is that the sign convention. When we write about the equation of motion, so we write h equal to ut plus half gt square. This is the standard equation. Now when body is projected upward, when g always vertically downward, so the sign convention is, now the important things is the sign convention. Important thing is sign convention. Where from where the body is projected, take this level as initial projection level. This is projection level. Now the projection level, upward direction of the projection level should be taken as positive, and downward direction should be taken as negative. So when body projected upward, the equation will be h, that is height ascent equal to positive plus h, u is positive and g is negative. So equation is this. Now when the body projected downward, suppose when a body projected downward, suppose this is a ground and a body is projected from a height tower, body is projected from this with direction this. Now this is the projection level. So upward direction is positive and downward direction is negative. Upward direction is positive and downward direction is negative. So when a body is projected downward, what is the equation? Equation will be, general equation is this, but h here negative, so minus h, u is negative, so minus u, and g is negative, minus g. So the result comes h equal to ut plus half gt square. So when a body is projected downward with a velocity u, then also equation is this, h equal to this. A certain height h, a body ascend a certain height h in two times. When one time is less, which is while the particle ascending, and another time when he descends, that is in two times the body attain the same height. In two times the body attain the same height from the ground. One is less time and another is more time, so t2 greater than t1. Okay, now what is the product of the two time? And time of t1 plus t2 equal to what? Now we know that t1 is this time and t2 is this time. So if this time is t2, now the time taken to move from this to this is also t1. So time taken to move from this to this also t1. So total time of flight will be t2 plus t1. So t2 plus t1 equal to time of flight, which is equal to 2 by g. And what is product of t1 t2? We get product, we use the equation this. Suppose height is h, this is the equation. Now this this. Now this is the quadratic equation of t. We take two roots t1 t2 because t1 t2 in time t1 t2 the body attain the same height, so t1 t2 are the two roots of this equation. So the product of two root equal to 2h by g, that is this by this. This is the answer. Now projected with velocity u. Now what is the time taken to reach the ground? This is the ground. What is the time taken to reach the ground? A body is projected from the top of a tower of height h. Body is projected u. What is the time taken to reach the ground? Now we can find this time by using a single equation. So this is the projection level. Okay, this is the projection level. Now upward direction is positive and downward direction is negative. So write the equation first. H equal to ut plus half gt square. So here body is projected from here and ultimately the body comes here. So what is the direction? What is the displacement of the body? Displacement is along vertical downward, that is along negative direction. So we take minus h. That is net displacement is this to this, net displacement along downward direction. So we get h equal to this, net displacement along this direction. U is taken positive, ut, and g is negative. G always act downward direction, so we take minus. So from this so time t equal to, by Shridharacharyya's formulas we get minus b. What is the formula? Minus b plus minus root over b square minus 4ac by 2a. Now t equal to 2u plus minus root over b square 4u square minus 2g into h by 2g. So by calculation we get t. Now negative sign should be avoided. The negative sign should be avoided because time cannot be negative. So this is the answer. So by using single equation we can, if you apply the proper sign, then we can get the time by using single equation. Student generally calculate the time here, two time, that is one time is t1, then they calculate this time t1 and they calculate this time also. So total time is t1 plus t2. That is, now to find the t2 he have to consider this velocity, initial velocity u. This is a long process. So if we apply the sign convention properly, then we can get the time by using single equation. And a body is projected with this velocity. Suppose this is 40 meter per second, 80 meter, this angle is 60 degree. Now the body moves in such a way, the body moves like this way, So what is the range here and time taken? So how we find this range and time taken? Now to solve more easily and short process, we first resolve the velocity along two direction, 40 cos 60 degree, 40 sin 60 degree. So the body move in this way. Now we know the in projectile motion the horizontal component remains same. The horizontal part, that is horizontal part ux equal to 40 cos 60 degree, which is equal to 20. Horizontal part acceleration due to gravity act vertical direction, so horizontal part ux remain same, horizontal velocity remains same. We know that horizontal velocity throughout the motion remains same. So first we find the time taken, that is time of flight, time taken to this, from this to this. Now what is the time taken? So to calculate the time taken, we have to consider the vertical direction, that is the particle. If we consider vertical motion, consider only vertical motion, that is the particle upward direction. First we write equation. Now the body moves with this velocity along vertical upward and net displacement along vertical direction is this. So h equal to minus 80, that is net displacement of the particle along vertical direction is this. Body projected here, but body will reach at h. So what is the displacement along vertical direction, the displacement along vertical direction is equal to this, only this, that is minus 80 along downward direction. And initial velocity, what is initial velocity? Direction is upward, so this is sin 60 degree t, and g always take as negative, so minus g equal to 10 t square. So we get 5t square minus 23 minus 80 equal to 0, that is 5t square minus 4 root 3 t minus 16 equal to 0. So you get t, just avoid the negative sign of t. Now the initial velocity, horizontal velocity is 20 into this time taken is the required range. So to find the time taken from this we have to consider only vertical motion, and net displacement will from this to this along vertical direction is negative. So minus 80, h equal to minus 80, u initial velocity, u is positive, so this, and g always negative. So if we put a proper sign convention, then we get the value, the time t. This time is time of flight. Now range equal to velocity along this direction, velocity which is constant throughout the motion, velocity into time equal to distance. That is, this is the horizontal. Suppose a body is projected horizontally with a velocity u from the top of a tower h. Now the motion of the body will be like this way, this. So what is the range and time taken? Now if we analyze the motion of the body, then the horizontal velocity remains same, that is this point, at this point velocity will same, g acts along this direction, so velocity remains same. Now what is the range? Range equal to velocity into time taken. Now again same way, the height is h, so to calculate the time taken we have to use the vertical motion, we have to use the vertical motion. So in vertical motion, what is the displacement? Displacement is negative direction, so minus h, u is 0, consider u means along vertical direction. What is u equal to 0, we have to consider along vertical direction. So along vertical direction initial velocity 0, because initial velocity here completely horizontally, no component of the velocity along vertical, so u equal to 0, t minus half g t square, g will be negative, g vertically downward, this is negative, so we get t equal to 2h by g root over. Now so range equal to u into root over, so memorize this formula only. Now velocity at any time, suppose this time here horizontal velocity vx equal to u, and vertical component vy equal to obviously gt, because u equal to 0 plus gt, and net velocity along this direction v. So velocity at any time v equal to root over vx square plus vy square, which is equal to vx equal to u square and vy equal to gt, this. And if we calculate the angle with horizontal, then tan alpha equal to vy by vx, so vy equal to gt by vx is u. So this is the path of the projectile. Now a to b, this is the range, we know. If we theta, we know ux uy, so this is the maximum height. Now what is the analysis of this motion? Velocity remains same along same horizontal line, velocity remains same throughout any point of the projectile path. So this all the velocity remains same, which is u cos theta. So here point is velocity. If you are asked that what is the velocity at highest point, velocity at highest point will be u cos theta. What is the, these are the points you have to remember. Now what is the angle between velocity and acceleration at highest point? Angle between velocity and acceleration at highest point will be 90 degree, because velocity direction is here and acceleration is this, so angle is 90 degree. Angle is 90 degree. Now along same horizontal level, along upward velocity and downward velocity is same. And now any projectile, first calculate the time of light. Time of light equal to actually 2 uy by ay. This is the net formula, 2 uy by ay. Here uy equal to u sin theta and ay means acceleration along y direction. We take x axis and y axis along this way. This is x axis and this is y axis. So 2 uy means 2 u sin theta and acceleration along y direction. Magnitude, this value, this acceleration should be as this is the magnitude of the acceleration. Okay, so this 2 u sin theta, this is the time of light. And range to get the range, what is the formula to get the range will be always ux into time of light. So this is the formula of range. So ux equal to u cos theta and t equal to 2 u sin theta by g. So we get the result u square sin 2 theta by g. We get the result is. Now this formula we know, and maximum height, time of flight equal to this time, this is time of flight, maximum height equal to u y square by 2g. So uy here u sin theta whole square by, actually this is the maximum height, 2g. So we get r equal to u square sin 2 theta by g. So r will be maximum, r maximum when theta equal to 45 degree, because sin 90 is maximum, u square by g. Now angle theta and 90 minus theta, ranges are same, path will be this, that is range will be same, but maximum height will be different. Suppose this is h1, and this is h2. Range, maximum height at angle theta will be this, and maximum height at 90 minus theta equal to u sin 90 minus theta. This, now what is the result? h1 is 2 equal to u sin theta cos theta, u square sin theta cos theta whole square by 4g square. This is the h1 is 2 and the range equal to this. So there is a relation between h1 is 2 and r, sin square 2 theta sin 2 theta whole square by g into 1 by 16. So this is r square by 16. So r square equal to 16, h1 is 2, this is one result, this is the one result, r square equal to 16, h1 is 2, this is the one result. What is projected to you at angle theta, then the path will be this, suppose path will be this, and suppose here we have to measure the velocity. There, if the velocity v is v and it makes an angle alpha with horizontal, then how will you get the velocity at any time, an angle alpha? So first we find velocity at any time t. Now u cos theta and vy equal to u sin theta minus gt. So velocity at any time v equal to vxi plus vyj, and magnitude of v equal to root over vx square plus vy square, which is equal to vx means u cos theta plus u sin theta minus gt whole square. So this is the velocity at any time. Now what is the angle? Here angle equal to tan alpha. We get tan alpha equal to vy by vx. Vy equal to u sin theta minus gt by vx equal to u cos theta. This is the tan alpha. T remain same at all points. So here v u cos theta. Suppose this is the velocity. We have to find out the velocity at here. Angle alpha is given. So here horizontal component will be v cos alpha, and here horizontal component is u cos theta. So v cos alpha equal to u cos theta, v equal to cos theta by cos alpha. This is the formula. what is the velocity at any height? So here we have to consider Vx, Vy, and so V equal to root over Vx square plus Vy square. Now Vx remains same throughout the motion, u cos theta whole square. What is Vy square? Vy square equal to u sin theta whole square minus 2gh whole square. So this is the velocity at any height. Angle is given alpha is given and velocity is v. Then the formula of radius of curvature at any point is we know acceleration n equal to v square by r, normal acceleration. So r equal to v square by n. That is for a circular motion. If velocity is v and radius r and acceleration centripetal acceleration n, what is the radius? Radius equal to normal acceleration v square by r. From this we get r equal to v square by n. So here v equal to along this direction v and acceleration should be taken as perpendicular to v. So and this is also this and this also perpendicular, though this is alpha. This and this line, this is normal line to the velocity. That is, this line is perpendicular to the velocity. So this is alpha, this is 90 minus alpha. Now this and this is 90, so this angle is alpha. So along the acceleration along this component is g cos alpha. So this is the n, normal acceleration. So answer is equal to v square by n, that is g cos alpha. Now what is the v? V will be, we get v, if angle alpha is given, then we know v cos alpha equal to u cos theta. So v equal to u cos theta by cos alpha. We know v equal to u cos theta by u cos alpha. So this is the velocity. Put here velocity v equal to u cos theta by cos alpha whole square into 1 by g cos alpha. So this is the velocity, this is the radius of curvature at any point. This is the radius of curvature at any point. Now change of momentum when it strike the ground. Change of momentum, suppose this is u, this is theta. Now this is the projection. So first find the change of momentum. So if the mass is m, the body strike at here. So what is the component of this? This is u cos theta. We know this is u sin theta, and along this is u cos theta, and this is u sin theta. So we know first question. We know change of momentum equal to change of momentum equal to final minus initial. Now what is momentum? Momentum is mass into velocity, vi. So we have to write velocity in terms of vector form, that is I and j form. If this direction is I and this direction is j, so what is final velocity? Final velocity will be u cos theta I plus u sin. We take along this direction is j cap, so u cos theta I plus u sin theta j cap, and this is the final velocity, and initial velocity is u cos theta I. If we take this along j, then this the minus j, u sin theta minus j, that is minus j. So this is the change of velocity, which will be u cos theta will be cancelled. So 2m u sin theta j, and magnitude of this change of momentum is this, and magnitude of change is 2m u sin theta. This is the answer. Okay, we find the change of momentum, so we have to write in vector form. And velocity and power at any moment, power at any time. If you have to calculate, if you are asked the power at any time t of the particle, power equal to f dot v. So first question I have done. Second question, find the time after which initial velocity and velocity at that time, that is final velocity, be perpendicular be perpendicular. Suppose this is a, suppose here velocity direction is this, initial direction of initial velocity is this. Suppose after t here body reach and the velocity is this, so this direction if we extend this, then to the direction makes, two direction makes angle 90 degree. So what is the time taken so that this direction and this direction will be 90 degree? If the body at here this is not 90 degree, because this is not 90 degree. So after a time t at after which the two direction will be 90 degree, or what is the time taken for that? So here also we have to consider the vector form, that is initial velocity equal to u cos theta I plus u sin theta j, and final velocity, that is v equal to, you know, u cos theta I plus u sin theta minus gt j. So two velocity will be perpendicular, so we use the vector formula u dot v equal to 0. So if we dot product, that is this into this, if we apply the dot product, this and this plus equal to 0, so we can write this t equal to u square by u sin theta g, that is u by g sin theta, u square cos theta plus u square sin theta equal to u square, so u square u sin theta gt, u sin theta g. So this is the answer, this is the answer. After this time velocity will be perpendicular. Now next question, what is the power at any time t? Suppose velocity u, and here what is the power? We have to apply the power equal to f dot v, f equal to ma dot v. Now m into a, acceleration direction is always in this direction, acceleration is g along this direction. So if we take this is I, this is j, or this is j, okay, this is j, then ma equal to m into minus j dot d. What is the velocity vector? Velocity vector equal to u sin theta I plus u sin theta minus gt j. This is the velocity vector. So we get j dot I equal to 0. So we get the result minus m u sin theta minus gt, because j dot j equal to 1. So we have to take the magnitude, because power cannot be negative. So this is the result. This is the power. Just apply f dot v, f dot v, velocity at any time equal to this. Sorry, take I along this and j along this. So acceleration will be minus g j. And what is the velocity? Dot velocity. Velocity equal to u cos theta I plus u sin theta minus gt. This. So this is the velocity vector. This is the velocity vector. So j dot I equal to 0, and so we have to take the magnitude. So these are the result. Power at any point, power at any time. Sometimes velocity. Now equation of projectile path, equation of projectile path. So if a body is projected u at an angle theta, the projectile path will be this. Now we have to this is x axis, y axis, we have to find the equation of this path. So if this time taken is t, then this is x and this is y. So x equal to velocity into time, and y equal to minus half gt square. Just remember these two formulas. So you don't have to remember whole the projectile equation of the projectile path. Just remember two steps, and just you get, by eliminating t, we get the equation of the path. U sin theta t equal to x by u cos theta minus half g t. What is t? T equal to this. So this is x tan theta minus half g x square by u square cos square theta. So this is the result of the equation path. Now if we simplify this, we get one formula. If we take common x tan theta, we get the result x by r, where r is the range of this path, okay. X tan theta 1 minus x by r, this is one result. So what is the projectile is this is given, because this form is y equal to ax minus bx square form. So given this, find angle of projection, and time of flight. Find angle of projection. So we have to consider this and this, that is x tan theta equal to 2. If we compare this with this, tan theta equal to 2 and half g by u square cos square theta equal to 5. So we have to consider this. Now tan theta equal to t, so theta equal to tan inverse 2. And also if we are asked that velocity of projection, then we get from this 5 equal to 5, this cancel. So u square equal to 1 by cos square theta sec square theta, which is equal to 1 plus tan square theta, which is equal to 1 plus 4, that is 5. So u equal to root over 5. A body is projected this way or this way, anyway. So we have to find the range. In this question we have to find the range. So always take along this the x-axis and this is y-axis. So here you have to consider the g. If you are interested the projection on the inclined plane, elaborate discussion have been made in my videos. You can watch these videos, okay. Just I illustrate one simple example. So if this is take x and y direction, velocity is u. So what is g? G is this, acceleration is this. Now we have to consider always ux uy, that is we have to take velocity along x direction, y direction, and also we have to take acceleration along x and y direction. Ux equal to what? If u is this and this is angle theta, so this angle is theta, so ux will be u cos theta, and uy equal to u sin theta, so ux equal to u cos theta and u sin theta. Now what is acceleration? Acceleration is this direction. So if this angle, this is theta, then this angle will be theta. So this is g cos theta and this is g sin theta. So acceleration along x direction is g sin theta and acceleration along y direction is minus g cos theta. So what is first? Find time of flight. Time of flight will be always uy by mod ay, that is 2 u sin theta by mod ay. Along y direction, what is acceleration? Acceleration is this, so this is g cos theta. So this is time of flight. Now range equal to distance travel along x direction, and distance travel, which is equation of the straight line uxt plus half ax square. We always use the motion in equation along motion in a straight line. So ux, what is ux equal to u cos theta into t equal to this plus half x, what is ax equal to g sin theta, and t equal to time of flight, we get time of flight this, so put this. So this is the result. Inclined plane and a body. Suppose this is a inclined plane and a body is projected perpendicular from the inclined plane u. This is the projection, this is 90 degree. Then what will be the path of this projectile? The path will be like this way. So we have to find out the range here. Now any problem on the inclined projection of inclined plane on the, we have to consider x and y two direction. We consider this is along x, this is y. So we have to just here resolve the acceleration along x and y. If this angle is theta, then this angle is theta. So this is g cos theta and this is g sin theta, g sin theta. So now first find the time of flight. Time of flight equal to 2 uy by mod ay, which is equal to 2 u. Here acceleration, here velocity along y direction is completely u. Now ay equal to g cos theta. So this is time of flight. Now range equal to distance travel and x direction, which is equal to uxt plus half axt square, which is equal to ux equal to what? Ux equal to along x direction velocity is 0 plus half x. X equal to what? X equal to g sin theta into time of flight. We get this. So this is the range formula. So that's why you can find the range and time of flight in different. Now if particle crosses two same pole, the particle crosses same pole in time, suppose 3 seconds and another is 6 seconds, and velocity suppose this is 30 degree and velocity is u. Now find the velocity for which this is possible to cross the same pole, as 3 seconds and 6 seconds. Angle of position is 30 degree. So what is the velocity? This is a two pole of same height, suppose this is A and B. Two pole A and B are same height. So the particle is projected with velocity u at an angle 30. Or what is time taken to cross the pole? Time taken to cross the pole A and B are 3 seconds and 6 seconds. So find the u, angle of projection. Find u, that is velocity of projection, for velocity of initial projection. So how this problem can be solved? This is one pole, this is another pole. Now we know this time is 3 seconds and this time is 6 seconds. So time taken from this to this is 6 seconds. Now this is 3, so this will be also 3 seconds, because time of ascending and time of descending from same height will be same. Time of ascending and time of descending from same height, this is the same height, so this time and this time will be same. So this is 6 seconds and this is 3 seconds. Total time of flight will be 6 plus 3, that is 9 seconds. This is the time of flight. Now what is the formula of time of flight? Formula of time of flight will be 2 u sin theta by g. So this is 9 equal to 2 u sin 30 degree, half g is 10. So we get u equal to 90. This is the result. Students, all the theory related to projectile missions have been discussed. Now if you apply the formula, then you can easily solve the NEET problem very easily. All the theory related to projectile motion have been discussed. Now if you can apply the formula properly, if you can understand the theory, then you can easily solve the problem. So if you have any problem, then watch my previous videos, that is which have been discussed elaborately of projectile. To get such type of video and to continue the series, subscribe my channel. Okay, thank you.